Today we will continue with motion in one dimension, and we will talk more about motion in one dimension when the acceleration is constant. Okay, so what are the equations of motion when the acceleration is constant? These are the four equations that we apply when the acceleration is constant. Okay, these equations we have to memorize them, and for every exercise, we need to know which equations we should use. Okay, today we are going to discuss a special case, sorry, a special case when the acceleration is constant. This case is when an object falls freely under the influence of gravity, regardless of the initial condition. So we just get an object and leave it. It will fall under the influence of gravity alone. In this case, acceleration is constant. It's equal to minus gravity, whatever this gravity is. If it's on Earth, for example, in the special example of Earth, it's around 10 meters per second square. Okay, so if they say it's 10 meters per second square, we use A equal minus 10 meters per second square. If they give it 9.8, we use it as 9.8. Okay, and if they say it's on another planet like Mars, they will have to give us the acceleration on Mars in order to apply it in our equations. So here is a case. It's a case where we have constant acceleration. So the four rules apply. These four rules apply, but for every A, we have to put minus G, which is minus 10. I'm not going to put them here in the equation so as you don't think now we have new equations. No, it's exactly the same equations, but for A, we will put minus 10. Okay, let's see how does it happen, these free fall. There is two ways for the free fall to happen. It can either start from rest. It can either start from rest. So we are discussing this first condition. It starts from rest. So imagine that this is a person. He's standing at a height h from the ground. Okay. And he drops an object from the origin, from the original position. And it goes down. This object will go down. This object will go down under the effect of gravity alone. So we have the acceleration is minus 10 because this object is falling under the effect of gravity alone. Okay, so let's see what information do we have. So this is an object. It's the original, it's moving on this axis. So we will call this axis our x-axis. We will take it positively upward. Okay, we will take it positively upward. Remember, when we talk about position, we should always define an axis. Okay, when we talk about position, we should define an axis. And since this is one-dimensional motion, we only have one axis, which is x-axis. So we have our x-axis. There is the object. It was at the original position. So we will take x origin is 0. It's starting from rest. It's starting from rest. So V initial is 0. Okay, V initial is 0 because it's starting from rest. And it falls with the acceleration minus 10 meters per second square. When it reaches the floor, it reaches position B. What do I know about position B? I know two pieces of information. One, I know what is the position of B. Okay, if this is x equal to 0, what is x of B? I know that from here to here, it is how much? From here to here, it's h. So what is x of B? It's minus h because it's in the negative direction. X-axis is positive upward. So downward, it's negative. So this is xb equal minus h. Okay. What else do I know about B? Just imagine you carry a ball starting from rest. What happens to the speed as it's going down? What happens to the speed as it's going down? The speed will be increasing, 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 increasing until it reaches the floor, right? What will the speed of the ball be when it reaches the floor? It will be the maximum speed, the maximum speed. Someone might tell me, no, when it reaches the floor, it will stop. This is true, but what we mean here is just before it hits the floor, okay? Just below it hits the floor, its speed is maximum speed, okay? So let's repeat this stage. So if an object, you take it to an altitude, in this case, it's at a height h. Imagine it, you are on top of a building, okay? The length of the length of the building is, I don't know, 200 meters, okay? And you drop an apple, or you drop your keys, or you drop a ball, okay? They will fall under the effect of gravity alone. And this is why the acceleration is constant, and it's equal to minus the gravity. Okay, now I will define that the original position x is 0. I will take that the original position x is 0. So this is O, x is 0. This is the original position, and it's starting from rest. It's starting from rest. Starting from rest implies V initial is 0. Okay. Then the ball will go down, 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 down. And as it's going down, it will be speeding up, speeding up, speeding up, speeding up, speeding up until it's about to hit the floor, until it's about to hit the floor. And that's when V will be the maximum speed, okay? And what will be the position at this position? It's in the negative direction, and it is, we know that the altitude is 200 meters. So x at this point will be minus this 200 meters. Okay. So this is one example how a free fall can happen. There is another example how the free fall can happen, which is I don't start from rest. I don't start from rest. I take the ball and I hit it upward. Okay, I hit it upward. Okay, in order to hit it upward, you cannot start from rest. You have to give it some speed. You have to give it a velocity. So the velocity now is not 0. The velocity is not 0. It's a number. It's positive because it's in the positive x-axis direction. So it's positive. Okay. Now, what happens as the ball is going upward? What will happen to it? Just imagine it. Again, we are standing at the top of the building and I hit a ball upward. What will happen to the ball? The ball will go up, 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 up. Then what will happen? What will happen is it will stop, right? It will stop. And then what will happen? It will go down again until it hits the ground. It will go down again until it hits the ground. So let's imagine the situation again. I'm on the top of a building. I carry a ball and I hit it upward with a positive velocity. The ball will go up, up, up until it stops. It stops. And then it goes down, 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 and the speed will be increasing, 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 increasing until it hits the ground again with VB equal Vmax. Okay, now I call the point where it stops A. What information I know about position A? It's the position where the ball stops. Okay, it stops. What does this stop mean? Stops mean V at A equal 0. This means that it stops, okay? And How much will be the x of this point? It will be the maximum x. It will not go above it because it stopped. Okay, it will not go above it because it stopped. So what happens when I throw an object upward? It will go up, up, up until it reaches maximum position. Let me do this in new drawings. It will go. What will happen if I throw an object upward? It will go up, 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 okay, until it stops. If it stops, implies its velocity will be 0 and its position will be maximum. Okay, then it will start going down, down, down. Okay, speeding up, up, up. It will be speeding, 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 speeding until it's about to hit the floor. So VB will be still be maximum, just like previously. And the x of B is still minus h. Okay. And in the whole case, how much is the acceleration? While it's going up or it's going down, how much is the acceleration? You have to keep in mind that the acceleration will be constant, minus 10 meters per second square. And this is why we are interested in this situation, because we are discussing moving under constant acceleration. Okay, constant acceleration minus 10 meters per second square. Let's start doing some exercises, hoping that the idea will get clearer. So, page 5 in your booklet, from exercise number 1. A ball is thrown vertically upward. So it's thrown vertically upward. So it is the situation, this situation. Okay, so I copied it here. So a ball is thrown vertically upward. What happens to the ball's velocity while the ball is in the air? So what happens to it while the ball is in the air? What I said in the previous slide, velocity will decrease as it goes up, then starts increasing as it goes down. Okay, so velocity decreases as it goes up. Actually, here I should add until it stops. Until it stops. Then starts increasing as it goes down. Okay. What is its velocity when it reaches the maximum altitude? What is the velocity when it reaches the maximum altitude? When it reaches the maximum altitude, it will stop. So what will be its velocity? It will be 0. Okay, it will be 0. What is the acceleration when it reaches the maximum altitude? What is the acceleration before it hits the ground? This is part D. Part E, does the acceleration increase, decrease, or remain constant? What's the answer to C, D, and E? What is the acceleration when it reaches the maximum altitude? Whether it reaches maximum altitude, whether it hits the ground, whether it's in the air, whether it's going up, whether it's going down, acceleration is minus 10 meters per second square. It remains constant. Okay, this is very, 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 very important, because if acceleration was not constant, we cannot use these rules. Okay, if acceleration was not constant, we cannot use these rules. Now let's solve two exercises where we use these equations. A robot probe drops a camera off the rim of a 239-meter high cliff on Mars. So we are on Mars, where the free fall acceleration is minus 3 meters per second square. What is this minus 3 meters per second square? This is the acceleration. It's not minus 10 because this is on Mars. Okay. On Mars, the acceleration is minus 3.7 meters per second square. So I put it here in the drawing. This is minus 3.7 meter per minus 3.7 meter per second square. The height is 239. So I know, what do I know here? I know that H is 239. So I know that XB is minus 239, right? I know that XB equal minus 239. Find the velocity. Let's see what you want. So what do we have as given? We have acceleration. We have the height, right? We have the height. So we have the displacement actually. We have the displacement from where to where? From O to B. So we have delta X from O to B. Okay, how much is this? So we have acceleration and we have delta X from O to B. What do we want? Find the velocity with which the camera. A robot probe drops a camera off the rim. They said drops the camera off. They didn't say with, so this is here the case where it starts from rest. So we have V0 equal to 0 as well. So we also have V0. Find the velocity with which the camera hits the ground. So what is he asking for? He's asking for the final, right? So I need to calculate the final. Okay, so let's look at our equations. Which equation has A, delta X, V0, and V final? It's equation number 2. So I write the equation. V final, which is VB square, equal V initial, which is VO square, plus 2A delta X from O to B. VO is 0 because they didn't say that he hit it upward. He just dropped it. So if he dropped it, it means VO equal to 0. Plus 2 times minus 3.7, this is the acceleration, times minus 239. You have to pay attention that it's in the opposite direction of the x-axis. So it's minus. Okay. I do the calculations. 2 times 2, 3.7 times 239. We pay attention that negative and negative, it becomes positive. So VB will be square root of 1768.6. It's 42 meters per second. Part B, find the time required for it to hit the ground. So I want to get delta T. So this is now my unknown. I want to get delta T. So I look at all my given. What do I have? I have acceleration, delta X, V initial, V final, and I want delta T. Which equation can get me delta T? The first one I can use, yes, but it's the most difficult because there is a square here. But I can use if you want. You just have to learn how to use quadratic equations. You can do this on your calculator. The second equation I cannot use because there is no delta T. The third equation I can use, and the last equation I can use. Here I use the third equation, but you are free to use the last equation as well. So in the third equation, V final, which is VB, equal V initial plus A delta T. VB is 42. Actually, VB will be plus or minus. Yeah, VB will be plus or minus. It's plus. Okay, it's plus or minus 1768.6, and in this particular case, it will be minus 42. Yeah, it will be minus 42 meters per second because VB is in the opposite direction of the x-axis. So it should be minus 42 meters per second. Okay. Now, find the time. Yeah, so VB will be minus 42 equals 0 minus 3.7 delta T, implies delta T will be minus 4.42 divided by minus 3.7. It will be 11.35 seconds. Okay. Let's do another exercise. So is this clear here? So when this is math, if I have x squared equal, so let me write it as a square, x squared equal 4 implies x equal plus or minus 2. Okay, so it's either plus 2 square or minus 2 square. Both of them will give me the same answer. But here, why do we choose minus 42 meters per second? We choose minus 42 meters per second, not the plus. It's minus 42 meters per second because it is in the opposite direction. The x-axis is upward and it's going in the negative direction. So the Vmax is here is negative actually. It's negative. Okay. We plug it here and we get the right answer. Last exercise. Stephanie throws a volleyball from a height of 0.8 meter and gives it an initial velocity. So this time it throws it upward. So this is the second scenario with an initial velocity plus 7.5 meters per second. So what information here I have? I have the initial equals 7.5 meters per second. This is first, okay, this is the information here. So I have the initial, I have acceleration, okay, I have acceleration. And what do they want? How high will the volleyball go? Okay, how high will the volleyball go? Actually, they want it from the floor. So they want from here to here. From here to here. So first I have to get from where to where? From here to here. Oh, sorry. First I get it from here to here because it went from the origin to the maximum, right? How high will the volleyball? So he's interested in this point over here. We want to get x maximum actually. How high is the ball? It means we want to get x maximum. X maximum equal how much? So what's happening at x maximum? What do we know? We know also V final at x maximum, right? So we have the initial, we have acceleration, we have V final, and we want to get delta x from O to A. Which equation can help me do this? I have the initial, I have V final, I have A, I need x maximum. I also use the second equation. So V squared final equal V squared initial plus 2A delta x. How much is V final? It's stopped. It's stopped because this is the highest position, so it's 0. V initial is 7.5, it's given. Instead of A, I will put 10 times 2, it becomes minus 20. Delta x from O to A. 7.5 to the other side, square to the other side, 20, I keep it here. So delta x from O to A will be 2.8125. This is only from O to A. But when he say how high, he means from the ground, okay? So what do I have to add to it? I add to it the 0.8 meter, which is the height of the building. and this will be the final answer. I just add it up. This will be the final answer. Okay, part B, how long will it take the ball to reach the maximum height? So what does he want me to calculate? Let me again put, what do I have? I have the initial, 7.5. I have the final, 0. I have acceleration, -10. I have delta x now, okay? And what is he asking me to get? He's asking me to get how long, delta t, okay? So which equation I use? I have the initial, the final, a delta x delta t. Again, I can use either 1, 3, or 4. I also use number 3. You can simply use number 4. It will give you the same answer. So delta t from O to A is how much? I use V final equal V initial plus A delta t. V final is 0 because it's stopped. Okay. V initial is 7.5. Instead of A, I will put -10. Delta t is my unknown. So 10 delta t equals 7.5. Delta t equals 77.5 divided by 10, which is 0.75. Okay. Tomorrow, we will solve more exercises on this idea so as you understand it better. Bye-bye for today.